I'm really excited to be here and to help reopen PyData Paris. So today we're going to talk about DIY personalization or AI personalization. And I'm going to tell you a little bit of why I've been thinking about this and why I think we should all be thinking about this. So we all know that AI is extremely popular. You probably saw this metric. ChatGPT reached 1 million users in 5 days. When we think also and compare kind of platform adoption or even long-term technology adoption, when we compare it with internet adoption, it took almost 10 years for the internet to reach 500 million users, which is technically what ChatGPT or OpenAI API services serve now, so only a few years after they open. Of course, we couldn't actually run ChatGPT without the internet and without a lot of computers, so this is all built on a series of technologies, and we'll talk kind of about those parallels together today. And yet at the same time, you're probably like the AI person or the data person in your family, maybe also in your group of friends. And I am certain that you have gotten questions about how the AI works, right? Yes? Anybody? No questions? Yeah, okay. Yeah, is it gonna come, like, is the AI gonna come for me? Is it gonna jump out of my computer? What is it gonna do? And those can be fun, but also, like, it's genuine worries that people have. So I tend to follow discussions on R Privacy, which is a subreddit about privacy, and there is hundreds of questions like this pretty much every month, where it's like, I think my phone's listening to me, I put it in a box, I turned it off, I don't know why I'm seeing these ads, right? This is a real concern. Maybe those of you who work in advertising or recommendation systems, maybe even you have concerns yourself about the types of data that's being used, which is why kind of this happens, right? So people presume that the phone is listening to them because the ads are really, really good. Well, maybe we should make slightly less good ads to be less creepy, but the main thing is that these things are personalized to some degree already, but not really in the control of the user, and so they don't have trust. And that continues, so obviously my focus of my work for nearly the past decade has been on privacy, ethics and security in machine learning systems, and there's a growing concern, obviously, about how we collect data, how we process it, and how we use it. And it's now in the headlines, finally, where people are actively talking about the privacy concerns. And so if we want general adoption of AI, if we want people to be excited about machine learning, we have to also build trust in machine learning. And that's not really something that we've been focused on. Or many of us haven't been focused on that because we've been focused on other problems in machine learning. And so my question to us is, are we at the general adoption stage where we need to start focusing our efforts as a machine learning community to reducing what I like to call AI anxiety or anxiety, anyways. And we want to then increase fun and productive use of AI. And I would say, like, for example, when we take something like ChatGPT, it's much more useful to think of ChatGPT as a fun thing than as a productive thing. Unless you really want to write, like, SEO spam, then, like, I think ChatGPT is very good at this. But I think, for the most part, ChatGPT is a fun tool, should be a fun tool, because it's not really made to actually do factual work. More on this as we go. So I'm going to take us on a bit of a detour. I'm going to walk us through the computer revolution. You're like, Katharine, why are we talking about computers? This is old person stuff. Sorry, I'm an old person now. We're going to walk through the computer revolution because computers have interesting parallels to how we think about machine learning processors and systems today. So bear with me, please. This is an IBM mainframe from the 50s, right? And it used to take up whole rooms. In fact, my dad worked at IBM and worked on chip cards and systems, not in the 50s, but a little bit after that. And these were large, expensive, centralized machines. They were not available to the general public. Sound like any types of systems that we have today. If you've been in touch with a GPU cluster or TPU, These are incredibly large, expensive systems with huge amounts of compute that take up, of course, a whole room or many, many rooms, given the data center size today. And most people didn't have access to these computers, just like most people don't have access to a TPU cluster today. These were a specialized small group of workers. So this particular photo is from aeronautical research, most likely sponsored by the US military. And this was a specialized group of people who were really good at math, who were good at science, and these were the things that they then focused on. They got to use these really amazing computers. Sounds a little bit like AI today. And again, they had tasks that they were working on. So they were often working on projections, sometimes rocket or missile projections or something like this, or they were working on recognizing weather patterns and eventually satellites, and. And all of this was kind of for research. Some of that research was sponsored by the government, some of that research was sponsored by research institutions, and some of that research was sponsored by large corporate interests. Mainly in the early mainframes in the US, but then of course increasing around the world with many different types of large computers. And so here is maybe perhaps one view of what we have in quote unquote AI today and a parallel to our computer. But then what happened? So then the computers got smaller thanks to semiconductor research and many other things. Computers could fit on a desk. But even when computers could fit on a desk, they were still kind of expensive, and they couldn't do that much that we can do on computers today. So when we look at the Apple II, you know, it didn't have a GUI, it didn't have like a very interesting user interface. And at this point in time in computers, they were seen kind of as hobbyist things. So if you were into games, or if maybe your parents worked with a computer because of their work, you maybe had access to a computer and maybe you learned computer programming in this era of the 80s, so to speak. And the initial program that people often talk about of bringing the personal computer revolution was a program called VisiCalc, which essentially is spreadsheets. So pretty cool, data people. I excel at work. Do you excel at work? No? Any of us? No? But so like working with data on your computer, doing some basic spreadsheet calculations and stuff, this was the first time that people were like, maybe people actually want this computer stuff. Maybe this can do something interesting for people. And that, I thought, is a pretty cool fact. And of course, from then, we moved on to GUIs, we had interfaces, you had software that you could download and install. I come from an era where you used to buy software and install it from a bookstore. Yeah, that was a thing. You could trade programs and data and music with other people. And then the internet came, and there was community and discovery and platforms. So if you remember, if you're of my age group, maybe you remember CD-ROM burning parties where somebody would have the like 10-time or 100-time CD-ROM burner, and you could trade software and programs and music, really fast lightning speed. And then came, of course, Napster, which of course was probably illegal, but at first none of us knew, so we just traded files on the internet and computers with people. And this was like a thing that drastically changed the amount of people that A, wanted a computer, B, wanted a connected computer, and C, were actively thinking of fun, productive, interesting uses of computers. And so I want to ask you all to talk with me. Where do you think AI, whatever it is we mean by AI, where do you think AI is right now? We have here on the left kind of centralized, expensive corporate, moving towards hobbyist and specialized. Then we move towards more general use, where it's easy to install, it's easy to use for an average user, whatever we mean by that. And it has a GUI, maybe something to make it easy to interact with. And then we have the full, where we have PCs today. It's fully customizable, fully personal. You can use it online, offline. You can create your own use cases. So how many people think that we're over here at the far left? It's centralized, it's expensive, it's corporate. AI is there. Okay, we got some hands. How many people think we're at the next step, like hobbyist, specialized workers. Yeah, that would be like this audience, yeah, yeah. How many people think we're at general purpose, that we have software and GUIs and things like that? Ah, interesting, interesting. And then how many people think we're like fully customized, connected, offline, everybody can use it however they want? Okay, interesting. Cool, so it seems like we believe we're maybe somewhere between 2 and 3, and there's some outliers, so we have a proper normal distribution. Good job, everybody. And so, but I would say, if I had to look from where I work, I would say we're still maybe migrating from 2 to 3, and maybe that's why I think some of you might have voted twice. Maybe you feel the same way, that somehow we're in between these. And why should we care about getting to the other side? Like, probably if everybody can use AI, maybe like we don't get paid as much in this room. Like maybe it's against our incentive structure to make AI for everybody. I would argue not, because there's a lot of reasons why people have bothered to make technology and applications usable and controllable by a user. For example, you may have heard of Signal, you may use Signal. Every day now I get additions that more and more of my US friends are joining Signal. I think Signal is a good use case to show that when people can trust a technology and when people know how their data is being used, they want to opt into that. They explicitly go out of their way to use that, and it creates, of course, its own network effects and so on and so forth. So having trust in technology is a vote in that a lot of people are using these days. And in addition, I don't think, if any of you come from an era of early data centers and early browsers and computer technology, there was significant problems with malware, there was significant problems with sites that would load malware and execute commands, and a lot of that involved the IETF and many other global internet standard communities to start pushing for safer protocols, and then that pushed browsers and many other types of use cases to start alerting users in meaningful ways about how to operate their systems safely, right? And so the whole push to SSL, HTTPS, TLS was a concerted effort from a large group of people and corporations as well, that decided that user safety was something that they needed to get users to keep using the internet and keep using their computers. And I would argue that in machine learning, we need to worry about this too. If we want general adoption, we have to think about user safety and security. We have to think about things like privacy and encryption, and we have to decide how it is that we're going to make these systems available in a way that can, again, build that personal trust. So I'm going to challenge us today to think about what is the VisiCalc of AI products. And perhaps some of you already think that ChatGPT is the VisiCalc. I would say, since if ChatGPT could run on my local computer with my data without exchanging privacy or cloud compute, perhaps. So I'm going to challenge us to think, what is actually the VisiCalc? What is the way that I can use my own data on my own device in ways that I want and get the benefits of AI? I brought a few ideas. Maybe some of you, especially those of you that think that there's already customizable AI, maybe you have other ideas. But I have one idea that I worked on of building my own RAG. So of course, everybody wants a RAG, right? And I was like, I want a RAG, but I don't want to upload my documents to OpenAI. That sucks. So I'm going to build my own RAG. So in a Jupyter notebook with a little bit of Python, I first build a RAG kind of the way that people talk about RAGs today, where also the LLM is in charge of the actual search and retrieval task. That worked awfully, so do not recommend. Which makes sense, because an LLM is not an information retrieval or a search device. I mean, it's literally just a blah, blah, blah. It's a language model with some nice reinforcement learning to make it more usable. But at the end of the day, we've been doing search and retrieval for a long time. So I use a simple semantic search, so BM25, to find a set of documents. I then use a by encoder, so a sentence by encoder, to find in those documents what are the relevant passages. I then take those, using re-ranking essentially, if you work in language, I then take those re-ranked passages and I pass them off to a lemma file on my computer, and then I can ask questions to my documents and use them while I'm on the Deutsche Bahn without internet, although I love you, Deutsche Bahn, but no internet usually. Anyways, so I can do my research and work and find what computers are relevant just on my local computer, because why in the world, if I have computers on my, if I have documents on my computer, should I ask the internet about the documents on my computer? I mean, that is not only a waste of a round trip time, but who knows how many compute cycles, carbon cycles, et cetera, et cetera. And so all of this I will open source tomorrow on the Deutsche Bahn, and you can have a look at it and maybe improve it if you have ideas. But I think this is the type of RAG that people find useful. This is the type of RAG that people want to use. And honestly, if you're working at a large corporation and building some sort of knowledge-based RAG, this is probably, just from a compute and a price perspective, maybe a good first start for you. Okay, next step. We're moving out of language because language is only part of our world. What about if we had actually useful recommenders? So I've never really worked professionally in RecSys, so I decided to look up some research. And I found it very, very charming that even in the RecSys research, they were like, you know, the best system is if we built a model for every person, but that doesn't scale. So we're just going to commingle all of the data, and we're going to find personal groups, and then we're going to do X, Y, Z, right? So what if actually we turned that on its head and said, no, we're going to build our own personal recommenders? A few years ago, I noticed that I was spending a lot of time trying to check in on this news source, that news source, this feed, that feed. And I built my own, essentially, RSS aggregator. This is mainly because I looked at the other RSS aggregators, and they had like really icky privacy terms and like really awful stuff. So I was like, I know how to build computer stuff. I'm going to do this. So I built my own feed reader. It also used to work with Twitter, but Twitter turned off the API. I hate you, Elon. And so I collect all these things, but I like to follow the Hacker News stuff. I like to follow Lobsters, if you ever heard of Lobsters. Not so good anymore, but then it was good. And Reddit, and then numerous blogs and news and other things that I like. And what I noticed is sometimes I was scrolling forever because there was a bunch of stuff that I didn't find interesting, and I was like, you know what? I bet I can build a recommender. So what did I do? I used scikit-learn. I created a grid search. I regularly also rebuild my TF-IDF vectorizer and a simple Bayesian model. I haven't really spiced it up beyond that because it's working well for me. And now I have a quick read mode and a slow read mode. So on my quick read mode, I can just go through all the things that are recommended. And on my slow read mode, I don't have that. And I've been doing this for a few years now. And it's been pretty interesting to watch, because the other thing that I think that would make recommenders more trustworthy is if we could understand how they're working. And because I have a simple Bayesian model and I have a simple text processing pipeline, I can actually look at what's interesting. So for me, obviously, like a 2-token, 2-word method is working well right now. And it's pretty interesting to look at just a few of my things. So you may not know, but I really like cooking. So in my free time, I cook a lot of meals, which means I follow several food blogs that I like. And so we can see cooking recipes. We can see diversity disparities. We can see privacy things. And we can see DNS, because as you might have heard, I'm into internet protocols. And so all of this is kind of interesting for me to view what is my recommender about. And you want to know what my recommender knows I don't like? Any guesses? Yes! One of the top tokens that I don't like is Musk says. So good job, everybody. All right, but this is fun, and I think if people could play with the recommenders, it would also be much less scary how the recommenders on their phone for their ads work if they could experiment with them. What about photo storage and search? I mean, probably most of us use some sort of cloud-based model. It's kind of annoying if you want to work offline. Like Google Docs has offline, but you can only use it with Chrome, and then sometimes it doesn't replicate right, and. So, and for my photos, I just decided like I'd rather not have them on the cloud. So I have a Nextcloud running on a NAS device. And of course, this is a lot of effort, and I have a NAS backup, and it's a whole system on my local thing. And I just really wish somebody would just like sell this as a consumer product that someone could just buy and install, and it auto connects and all of this, but we're not there yet. But Nextcloud has some pretty good infrastructure for this. They run documents and shared photos, and they're used in a lot of the EU and German government as well, because you can actually run your own cloud with them. And I have some photos there. So here's a photo from my book signing with my forward author, Nikima, who also works in machine learning research and ethics in machine learning research. And what I decided is I had these photos there, and I decided I should build an image search. Now, I'm not a computer vision person, so please come find me if you are, and you can then tell me what I should be doing better. But I basically got the blip image captioning large from Hugging Face, and then I was able to add captions. The captions could use a little bit of descriptive effort, but here's two women standing next to each other holding a book. Okay, at least we're at a starting point. I then was able to caption everything, and I will be open sourcing a little script that you can run yourself to caption your own photos and to be able to search through them, obviously then also using semantic search. And a few years ago, I also figured out, I'm really envious of my friends with iCloud stuff, where they show, like, here's your week in 2014 or whatever. So I also, using image metadata, wrote an email program that emails me if it knows that I'm at home and says, here's some cool images from the past. One of the things that I'm working on, and if you work in image recognition and search, I'd love to talk with you about, is there ways, I think that I built something for Get Your Guide a long time ago that used to look at the statistical properties of an image and decide whether an image was good or not. So if you know about these algorithms, please come talk to me. I'd like to integrate that into this and open source it. So the thing that I think about this is, how many times do people get their iCloud hacked? There was like the big issue of a bunch of celebrities being targeted and getting their iCloud hacked. I think that people should have safe ways to have personal images and store them. And a lot of people also don't want their kids' pictures on the cloud. So there should be ways that parents can use something like this and make it easy to use. Again, not having to have the skill sets of the persons in this room. And as a final one, I'm a big swimmer, so I belong to a swim club in Berlin, and we do lots of swimming together. And I noticed all my swim friends had cool watches, and I looked at the privacy terms, and they were awful. So I just thought, well, somebody has to have had this problem. And indeed, Gadget Bridge, you might know about it, is a program where you can connect your smartwatch and have a local connection to your phone, because why do the data's on my watch? I have my phone. Why not local transfer? Anyways, you can locally connect and download your data. I don't wear my smartwatch all the time, but some people do, and then you can have sleep charts and all of the normal stuff. And here is one of my swims from this summer with some friends at one of the big, beautiful lakes outside of Berlin. If you're ever in Berlin and want to go for a swim, let me know. And I can now also see my GPS track, because now I have a Garmin swim watch, and I can pull the GPS tracks. And I plan on doing maybe some analysis and open sourcing this as well. But I wanted to promote something like Gadget Bridge, which also allows people to use their data in ways that they see fit and ways that they want. And when you look at the terms of something like Garmin, of course, we have protections here in the EU. And we have a lot of protections compared to people in a lot of places. And there are definitely ways and uses in the US and in many other places where your health insurance and the cost of your health insurance is dependent on whatever health data they can acquire, and some of that may or may not be your smartwatch. So finally, there might be a VisiCalc idea that you have that I haven't heard of yet. So if you want to share that with me today, please come by and say hi. So I decided, I've talked about this topic often with machine learning people. There's often the question of scaling. So there's a reason why we do AI in data centers, why we do AI in specialized data centers, and that's because of scaling. I know, I literally ran the first open source Hadoop. I know all about data scaling issues, and yet at the same time, the revolutions that we're seeing in the semiconductor industry still today, and in chip design industry still today, are showing us that we can design better chips that are smaller, that are more energy efficient, that hold more memory, and are faster. And if this continues, which I believe it will, then we only follow the same efforts of the personal computing, and perhaps that doesn't mean that pre-training is running on your local device, but it certainly could mean that some sort of inference step is running on your local device, and or other types of either fine-tuning or processing in your pipeline. People want to talk about filter bubbles. So every time I seem to say that people should run their own machine learning, people tell me, well, that's going to be really bad because of filter bubbles. Well, I wonder if those persons who are asking that know how filter bubbles work, because if you're already, and I now speak as an American who lives in Germany, so apologies for my frankness, but if you're already a raging neo-Nazi, the chance of you becoming a raging neo-Nazi by running your personalized ML is very slim. You're already a raging neo-Nazi. So when we look at something like the AfD, which is, I would say, the raging neo-Nazi party of Germany right now, so far right that even Le Pen says, you can't sit with us. So I think if Le Pen says you can't sit with us, we have a problem. So when we see, though, what's happening with the AfD, we see that young people are voting extremely strongly, particularly in certain parts of Germany. Brandenburg is right by Berlin, if you don't know. And young people are voting in droves for the AfD. And why is it that young people are raging neo-Nazis? I don't think maybe that all young people are raging neo-Nazis. Probably some of them are, and they get no exception or love from me. But some of the conversion funnels, some of the radicalization pathways that are happening are because of content recommendation that, by the way, is not local, that, by the way, is not personalized, that is instead an engagement-based recommender model that machine learning people build to increase time on site, engagement, outrage, reshares, comments, interactions, end. And when we look at that, TikTok, 30% of the AfD is there, compared to only 10% of kind of the centrist socialist party, the SPD. And when we hear research about how young people are finding out about politics, more and more people in Germany, at least, the young persons are finding, the kiddies, are finding out information on TikTok. And when we look at the Europawahl, when we look at the European vote, election, we found that, you know, young people are shifting to far right. And some of that is ha-ha, and some of that is just this social media, and some of that is many, many other problems that are happening that are much more complicated than machine learning can solve. But I would say filter bubbles are more of a problem of central machine learning than a problem of personal machine learning. We can also talk about malicious intent. So what if people build something evil to build malware end? Well, if you haven't heard of it, there's already WormGPT, which you can buy for, I think, under 100 euros now on, quote unquote, the dark web, which is a fully jailbreaked version of one of the GPT models, one of the OpenGPT models. And this is quite easy to do, right? And for the most part, if you were already intending to build malware or bombs or whatever, you could already find that information via many sources. So I don't think that this is a real problem that changes with personalized machine learning. So what do we actually need in order to go from essentially this more centralized model to a more personalized model? Well, one of the things that we need is tooling for everybody. If you haven't used GPT-for-all, it's kind of fun. You can run it on your desktop. It uses GPT-J, like Neo-J or something like this, which is an open model, but there's numerous models you can choose from, has the same fun chat interface, is not sharing the data directly with OpenAI, so this is maybe one example of how we can build things, but I think we can get more creative. I think we can actually, as a machine learning community, start thinking about how do we do tagging? So I'm a big fan of Prodigy from the Spacey and Explosion team. What if we could do better tagging and better fine-tuning and have that all be an interface that not a data scientist or not a machine learning person can use? What if when we give inference results, we actually show statistical likelihoods or summaries or some visualization of uncertainty? There's decades of research on visualizing uncertainty so that people can make a better decision. Have we integrated that into the AI products that we build? I would say not yet. We need easier data access and use. So it's all of our rights in this room as EU residents under GDPR to download our data. I have been recently trying to build like an auto Instagram export for people and then their own recommendation via that. But when you download your data from Instagram, not only does it come in a bunch of files, but then it's in HTML. Are you serious? Like, this is not data portability. This is not easy data use. What if instead we had easier ways to export the data? We built export pathways that worked, and then you could auto-import into some sort of content recommendation, or maybe some sort of visualization to see what things you like, what things you don't like. And that's part of some of the work. I don't know if you're familiar with Martin Kleppmann, but he wrote the Designing Data-Intensive Applications, and he's been working on research on what he calls local-first software. And many people have been working on these types of offline and local-first software, where you can use software first on your computer with your data. Why, if I'm using my data on my computer, why do I need an internet connection? That makes no sense. So why can't we use local first and offline use cases and then expand to connected use cases? And so in some of his slides where he presented recently, and I was chatting with him about it, he shared this slide with me where it says, hey, instead of using Google Docs where we all have to connect to Google, can we have peer-to-peer where if I'm working with some people on my local network, I can just trade documents and edit them with them. And all of that research, if you're interested in algorithm design, is under conflict-free replication data types, or CRDTs. We need more inclusive base data sets, and we need more inclusive base models. Although I love GPT-4All and some of the work that they're doing, like when you click, one of the first things I clicked in their little interface of what documents they used is like upskirting, like non-consensual sexual representation of images. Like this is just, like this is garbage. I mean, this is garbage data. It's very poor data quality. This is not the type of thing most users want to use. And yet this is the type of thing we find on the internet because the internet for a long time was filled with a lot of garbage because that is a good way to make money on the internet. And so we need to rethink how we build better quality data sets, how we build better quality data. And one of the ways that we need to do that is we need better privacy protections because nobody's going to want to give their data to something when they know that it will just be published. And in case you're unaware, memorization in deep learning is a known and studied phenomena. In fact, the first paper that I found on memorization at that point in time, neural networks was from 1991. So this is a known problem that we've been studying for a long time. The left is a diffusion model. It has seen that image once. It can reproduce it. The right is a real ChatGPT execution that then exposes private information by essentially using the poem as an end token that then allows the speech model, the language model to then execute beyond that end token. I mean, these are known attacks. I'm writing a long series blog post on the memorization problem that we have in deep learning and some ideas about how we might want to address it. But if we don't have better privacy protections, people aren't going to want to share their models with other people. And then we can't have the fun networking end. Because if we had that, and if we could network models and data together, we could do really fun applications. One application I've been working on for some friends of mine who are both researchers, they want to compare papers, but they don't want to centralize their papers. Well, what if we had a way to locally do some sort of projection, like a PCA, for example, or any other type of encoding and simplification of the data, And then one person could run it on their computer, the other person could run it on their computer, and you could either compare, find overlaps, find interesting topic co-locations, and then also, perhaps one day, send a query to your friend's computer and say, hey, can you send me these files when you have a chance, right? So these are the types of things, the use cases that I think allow us to build connectedness and community, much like how the personal computer allowed us to do that with the original internet. And so the future of AI, in my opinion, isn't a bigger mainframe. It isn't us building the most biggest model of all times that's going to be the most intelligentest of all of the times, because unless we solve memorization, we're essentially just memorizing half of, or 30% of the knowledge that we have stored in the network. So that's not the solution to actually having, quote unquote, the AI revolution. I think the AI revolution is about making AI usable for persons on their devices or with friends in ways that they want. And I think it's this communal intelligence that's actually going to be the interesting part, because to some degree, AI is just a different type of computer. It's a different type of computing. And until we have AI that everybody can use, we just have a centralized corporate controlled device that is maybe really good at SEO spam, but is not very good at anything else. So if you're in Berlin this weekend, I'm hosting a feminist AI LAN party. Yes, a local area network party. We have a GPU rig. We're going to set up some local models. We're going to run some attacks. We're going to build some data sets. And we'll definitely be releasing also some open source DIY kits for running your own AI LAN party. So thank you very much for your time and attention. I'll be happy. I don't know if we have time for questions, probably not, but you can pick up my book, which is about privacy and machine learning and data science. And you can also reach out at this email or sign up for my newsletter if you want to read more, hear more about these topics. Thank you.
So if there are any questions, I'm going to run up the stairs up to you and give you the mic. Please shout, because I don't see anyone. Yeah.
Thank you for the great talk. You were really focused about inference AI. You are using a lot of models. I would like to have your opinion about the same evolution you said about centralized to hobbies, etc. About the training stages of AI. How about being hobbyist about the training itself?
Yeah, and that's why I included scikit-learn and training my own model. And also, I really think this is important because I think, maybe not everything needs a general purpose large model. And we can find ways instead to give people ways to use much smaller models to do more specific tasks. I mean, that's how software got built, right? Like small specific task, something small that can run on your computer, something small that can run on your mobile device. I think that would be much more revolutionary than just getting pre-training to fit on a single computer, which is probably not going to happen anytime soon. And yet also, one thing that I found quite interesting, being somebody that's worked in language deep models, so I was doing deep learning in language back, more than a decade ago. And one interesting thing that I found is with the new models that we're releasing, fine-tuning is extremely difficult because we don't actually release the underlying language model. We release this whatever instruct blah, 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 and then it becomes much more difficult to actually fine-tune the behavior. And if we pushed companies or if we regulated companies so that they must release the underlying language model, not only would it be much, much easier to identify the ethical problems, find sexism, racism, other issues in the data set, we could also find privacy problems a lot easier if we had the underlying language models. And we could probably overall build more awareness and better protections. And I find it really an unfortunate development of language modeling that with this invention of the reinforcement learning steps, we no longer have the easy ability to fine-tune. And of course, yes, I'm sure some of you are like, but what about many-shot or prompt, whatever, you know? At the end of the day, that's not changing the model behavior significantly, and it's certainly not actually updating model weights. So I find that to be trivial compared to fine-tuning. Thank you.
Please bear with me. I'm trying not to fall.
I don't see any other questions. So, yeah.
Thank you very much for the insightful and fun presentation. Good way to start. So going back to when you talked about from the mainframe, centralized AI, all the way to personalized AI, one thing that prompts me is these tools that are centralized, they have money, they can build products, they can have great UX. And being an open source user myself, I know for a fact that it takes ages for anything open sourcey to have good UX. It's like if you do some music production, for instance, you do have Ardo, which is 100% open source, but the experience is really much harder than anything paid software. How do you see the development of personalized AI when in the competition against fine products, Google products, very shiny things? You were showing, for instance, this RAG that you made, which is great, but not everybody can pull up a notebook and install pip. And I have a friend who had to do 1 gig clone to be able to use Stable Diffusion and LoRa. Amazing once it was done, but getting there, it was so painful. So how do you see the development of personalized AI?
Yeah, and this is why, although I'd be curious to hear your opinion later if you find me during coffee, this is why I think we're still at the hobbyist stage. Like, I would say we're still very much at the hobbyist stage because in general, machine learning can only be used by people that can program Python or maybe like C++ or a few other languages, and it can only be used by those who are comfortable in a coding environment end. And I agree with you 100%, but I share with you like a quick story. Unfortunately, this company got acquired by Apple and killed. But I share this story because there was this really cool product, and now, honestly, I forget the name of it. I will look it up, and I will post about it. And they sold an at-home email server. And it was like really sleek, cool design. An email server, if anybody here has ever tried to run their email server, this is like the worst experience. It's still, we've been doing email for like decades. It's still the worst experience. And they had this little at-home email server. It was really sleek, very like Apple-y looking. And it just ran on your local thing, and it ran all your email for you. And it could, of course, you connected it with the public internet, but it was locally encrypted and stored on your thing. And also, you know, you could set it up even with PGP, which PGP, worst user interface ever. If you want to send encrypted email, just give up. But the intention was good for PGP to build encrypted email end. Then they got, I think, something like 100,000 pre-orders. And actually, before they started shipping, they got acquired by Apple. And they moved the whole team in turn. But I think the point that I'm making and why I'm talking about this is like, I think we could sell paid AI software that works on local devices. I think we could even sell paid AI hardware that works in people's homes. I think that's actually Apple's strategy right now, is just personalize AI on device, only trust us, don't trust the OpenAI, the Microsoft, the Google. I think that's their whole marketing angle right now. And if you work for Apple, I'm sorry if I'm talking garbage, but I think there's a non-trivial amount of people that would be those early adopter general consumers that really would buy these things. Like I would buy an AI swim watch if it didn't connect to the cloud. You know, these are the types of things that I think people want and yet is not available on the market yet. And that's what I want to see and why I'm giving this talk. Maybe you want to see it too.
Here. Thanks a lot. Thanks a lot for the great talk. you showed very well why we want to do these things and when they're technically possible. My question is, how do we get around all the networks effect in economics, the fact that, basically rent-seeking behavior, asymmetric economical effects, tax evasion.
I mean,
Basically, how
I'm
do we
not a
make this
politician.
capitalistically viable in our current world?
Yeah. Yeah. I mean, I think, so I want to just share like one little fact that I read about today. LinkedIn announced or like turned default on for most of the rest of the world, the fact that they can use now LinkedIn data for Gen AI use cases without any consent. They didn't roll it out in the UK and Europe because they know it's illegal. And a lot of people in my US privacy networks who work professionally in privacy in the US are, of course, in outrage and one of the things, I think the European perspective, which I'm originally American, but I'm now getting my citizenship in Germany, but one of the things that I think the European perspective around digital rights, around human rights as part of technology, I think is a fundamental shift in who holds the responsibility for data and then who holds the responsibility for technology. And from being in EU circles and being invited sometimes to speak at Brussels, I think the EU would like to support European-based initiatives that also support what the EU often calls sovereign data and sovereign data principles. And if you're aware of the Sovereign Tech Fund, this was a large EU-supported and Germany-supported initiative to give money to open source end-to-end. And what I guess I'm asking us to think about as a data community is, are we willing and able to think about sovereign data as part of our data community? And if so, are we willing and able to do things like build things for the government? I mean, it worked for the initial internet. It worked for building out ARPANET. And if, we may have different feelings about working in public sector and all of these things, but all of these issues are massively problematic in public sector. And one reason why Nextcloud has such high adoption is because it is private and localized and has those things. And so one of the questions that I have for us is like, are we gonna outwin capitalists at capitalism? Like, probably not. I mean, can we compete with, startup funding? I mean, startup funding is drying up anyways, so maybe we can one day. Or are we willing to think about different ways of funding things and different ways of building our software so that they can be funded and used by persons and by groups that are willing to pay extra for these types of features? And maybe that isn't a startup model. Maybe that's something else. But I'd be happy to talk more about it. I don't have the answers. I just have some more questions. Yeah.
Thank you, Katharine. We have reached the hour. So please give her a round of applause. And